Hello friends, today we are going to analyze a simply supported beam which is loaded with 50 kN point load at distance 4.8 meter from the left support and 1.2 meter from the right hand support, which is a simply supported and having the flexural rigidity EI as a 20,000 kN meter square, which is earlier calculated by the Macaulay's method. Now we are going to calculate the amount of maximum deflection as well as its position using the conjugate beam. So let us convert this given beam into the conjugate beam as, according to the given loading, our support reaction at location A as a 10 kN, support B as a 40 kN. Now first of all we have to convert this beam into the conjugate beam, and we know that hinge support becomes hinge, roller support becomes roller, so there is not change in the hinge and roller support. If we convert this beam into the conjugate beam, then the length of the conjugate beam is 6 meter. According to the definition, length does not change. Now second change is in the support, but we have hinge and roller support which does not change, and the location is marked as a dash and B dash in the conjugate beam. Now the next point is we have to draw a bending moment diagram of this beam, and we know that for the point load the diagram is of triangle in the nature, and the peak value, or we can say that the maximum moment value is WAB by L, where W is equal to 50, A as a 4.8, B as a 1.2, and total length of this span is 6 meter. Hence the value for this calculation is 48 kilonewton meter. Or if we take the moment at location C, then it is 10 into 4.8 as a 48 in the left hand side clockwise as a positive. So here the value of the maximum location is at 48 kilonewton meter, and according to the definition, this moment is divided by the flexural rigidity as a M over EI diagram, and this M over EI diagram is loading in the actual to the conjugate beam. So our actual beam is converted into the conjugate beam. Now we have to calculate the amount of maximum deflection, and we know that at the location where slope is 0 we must have the deflection as a maximum. But for the calculation of slope we have to first calculate the support reaction in the conjugate beam. So let us assume that support A dash, our reaction is as a RA dash, at roller support at location B our support reaction is RB dash. So let us take the moment at location A dash, then for the first 4.8 meter UVL loading, total loading is 1/2 into 48 by EI into 4.8, and from location A the CG of this triangle is 2/3 of 4.8. Now for second 1.2 meter UVL, which creates the clockwise moment, hence it is positive, total load is 1/2 into 48 by EI into 1.2, and CG distance from location A dash is 4.8 up to the point C and 1/3 of 1.2 of the UVL. So it is at 4.8 plus 1/3 of 1.2, and the RB dash creates anti-clockwise moment, so total distance is 6, so 6 into RB dash as a negative. Now solving this term we will have our value for the RB dash, which is 86.4 by EI. Similarly, if we take the sigma V equal to 0, then RA dash plus RB dash in the upward direction and total triangular loading in the downward direction, which is negative 1/2 into loading as a 48 by EI and total span as a 6 meter. Now replacing the value of RB dash as a 86.4 in this equation, we will have the reaction at location A as a 57.6 by EI. Now we have to calculate the maximum deflection location, and we know that the slope is 0, we will have the maximum deflection. So let us assume that from the location A dash to the location C dash there is a point where deflection is maximum. So if we assume A dash as a origin, then distance of this section is at x meter. So let us analyzing this view. Now for this rate of loading of UVL, if we take the similar triangle rule, then at 4.8 meter total loading is 48 by EI, then at distance x our loading is 10x by EI. Now if we take the shear force value at this location of conjugate beam, which gives us the value as a slope. According to the conjugate beam definition, slope in the real beam at any distance is equal to the shear force at same location in the conjugate beam. So if we take the shear force at this location, then it is 57.6 by EI in the upward direction and UVL of 10x by EI in the downward direction. So it is negative, and the total load is 1/2 into rate of loading as a 10x by EI and the distance as a x. So our value is 57.6 minus 5x square divided by EI, and we know that our slope value must be 0 for the maximum deflection. So let us put the shear force as a 0, and solving this value we will have 3.394 meter from location A. So at distance 3.394 we must have the maximum deflection, and the maximum deflection can be found out by the bending moment in the conjugate beam. So let us take the moment at this section. We will have moment maximum, which is equal to deflection maximum in real beam, which is 57.6 by EI into total distance x, which is 3.394, minus, due to the anticlockwise moment of UVL, it is 1/2 into loading as a 10 into x as a 3.394 divided by EI into distance as a 3.394, and CG distance from this location is 1/3 of x, is as a 1/3 of 3.394. Now let us calculating this value. We will have the maximum value of deflection as a 6.51 into 10 raised to minus 3 in terms of meter. So it is as a 6.51 mm. So thus we can calculate the maximum deflection using the conjugate beam by taking shear force equal to 0, or we can say that the slope equal to 0 in real beam. Thank you.